Assalamu alaikum. This is Microeconomics Theory course directed to fourth year economics section. Let's start at chapter 5 in our textbook, The Producer and Optimal Production Choices. In this chapter, we will go through the following points. First of all, we will take definitions about production function, what's meant by total product, marginal product, average product, what is the difference between production in the short run and in long run, what are the main analytical tools and techniques in post period of time, what is the aim of the producer, and what are the basic assumptions behind the aim of the producer. Second, the optimization behavior of the producer in short run. Third, the optimization behavior of the producer in the long run. Finally, we will learn how to measure the elasticity of production in the case of Cobb-Douglas production function. We will start by defining production function. It shows the physical relationship between output and inputs, which are factors of production: labor, capital, land or natural resources, energy, entrepreneur. And for our analysis to be easy, we have written the production function as output function of labor and capital. Here we have two concepts: short run and long run. What are the difference between short run and long run? Starting by short run, it is a time period that actually less than 1 year, in which a firm cannot change all its inputs. We find that labor is the only variable factor of production, while capital is constant or fixed. Output in short run is given by the law of diminishing return, while in the long run, it is a time period in which the firm can change all of its inputs. In this case, labor and capital are variable, and the output in the long run is governed by the law of return to scale. Let's start by production in short run, and starting point is the basic assumption. We have 5 assumptions of profit maximization in short run. First, producer is rational, which means that he aims to maximize profit given the technology and the prices. Second, the price of output is given. Third, the prices of inputs are given. Fourth, the producer has access to as many units of input as he needed for production. Finally, the producer has full knowledge of the technology. As we said before, production function in short run is a function of variable input, which is labor, and capital is the only fixed factor of production. So output depends on the variable factor of production, which is labor. Thereby, what would happen to the level of output as we add more and more units of these variable inputs? These questions can be answered by the law of diminishing return. which govern the relationship between output and input in the short run. According to the law of diminishing return, as we add more units of variable input, which is labor, with a given amount of fixed input, which is capital, the marginal product of labor and average product of labor are eventually decreased. Thereby, as we add more labor, production passes through 3 stages. First, total product increases at an increasing rate. Marginal product of labor increases till reach its maximum at the end of first stage. Average product of labor is increasing, but it's less than marginal product of labor. In the second stage of production process, as we add more units of variable factor, which is labor, total product increases at a decreasing rate till reach its maximum at the end of second stage. Marginal product of labor starts to decrease till reach 0, and average product is increasing till reach its maximum at the point of its intersection with marginal product of labor, and then it starts to decline. But in the second stage, the marginal product of labor is less than the average product of labor. At the second stage of production process, as we add more labor, total product is decreasing, marginal product becomes negative, and average product is decreasing but never becomes negative. Now let's take an example about production function short run. Consider the following short run production function where Q is production and labor measures the number of labor hours. The required is to find the number of labor hours that maximize output and find the number of labor hours that maximize marginal productivity of labor, and finally he asked me about the number of labor hours that maximize average product. First of all, in order to get the number of labor hours that maximize output, we have to remember that the output is maximized at the end of the second stage of the production process, where the marginal productivity of labor reaches 0. So we have to get the first derivative of total product function with respect to labor and equate this equation to 0. Or in other words, we could find the marginal product and set the marginal product equal to 0 and solve for labor. We get the marginal product of labor, of which is the first derivative of total product function. This is the first step. And then we set the marginal product of labor to 0, and we will solve for labor. Thus, the number of labor hours that maximize output equals to 10 hours. Second, he asked me about the number of labor hours that maximize marginal productivity of labor. In this case, we have to find the first derivative of marginal product with respect to labor and equate this to 0 and solve for labor. First step, we have to find the marginal product of labor, and then we get the first derivative of marginal product of labor with respect to labor and equate this to 0. Thus, the number of labor hours that maximize the marginal product equals 5 hours. Third, he asked me to get the number of labor hours that maximize average product. In this case, in order to maximize average product, we will get the first derivative of average product with respect to labor and equate this to 0. First step is to get the average product of labor, and then we get the first derivative of average product of labor and equate this to 0 and solve for labor. In this case, we got the number of labor hours that maximize the average product of labor, which is 7.5 hours. We could solve this point by another solution, where the number of labor hours that maximize average product of labor is get when average product of labor equals marginal product of labor. When we equate average product of labor with marginal product of labor, we get the same solution, which is 7.5 labor hours. Try to solve this assignment and send the answer to me. Consider the following short-run production function is given by the following equation, and requires is to get the number of labor hours that maximize output and the number of labor hours that maximize marginal productivity of labor, and finally the number of labor hours that maximize average products.